Okay, geometry, we are looking at this idea of proving, but now we're going to prove lines parallel. This is a little bit backwards from what we've seen before. So the idea before was that you had two lines that were parallel, and then you had a transversal, and then that told you a lot of stuff about angles and such. But now we're going to go backwards. And when you switch, instead of going the normal hypothesis and conclusion, and you do that logic in reverse, call that the converse. So that's the big idea for today, this converse, 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 just like the shoes. Okay, so let's try the first one here. So if we scroll up, there we go. It says for exercises 1 and 2, use the converse of corresponding. So they're telling us where we're going to go with it, but we have to kind of set up the template here. So let's make sure we got straight lines. Cool. So I'm going to do just a simple kind of two-column proof that we've been working with. Let's see what we have. So first, we got like our statements and then our reasons that match them. So I'm going to do the first one. It says angle 2 is congruent to angle 4. I'm going to start with what they gave me. And not only am I going to start with that, I already know what I'm having here. It's just given. Now I can jump right into the final statement, which is right here. They're asking me to prove that C is parallel to D. So 2a would say C is parallel to D. Actually, it's lowercase, but yeah, let's go ahead and write that in properly so we're not confusing anything. C lowercase is parallel to D lowercase. And how do we say this? Well, they already kind of gave us what they want us to say. But because these are corresponding angles and they're congruent, then the lines are parallel. So that's the converse of corresponding angle postulate. Just like that. This next one has a little bit more involvement just because we got to take a few steps to get to where we can say that. So let's go ahead and set ourselves up here. So first, we're going to state what we're given, which is all of this. There's a whole lot of it. So we got measure of angle 1 equals 2x, measure of angle 3 equals, we got run out of space here. Let's see if I can fit this on the second part of the line. Measure of angle 3 equals 3x minus 31. And then we also say that x equals 31. And all of that is given. There's 1b right there. So then 2a, I'm going to take that information and start doing some calculation with it. I could say measure of angle 1 equals 2 times 31. And measure of angle 3 equals 3 times 31 minus 31. Okay, not too bad there. That works for me. Now, if I were, and that's just what did we do there? We took the x and we replaced it with 31. So that replacement is a substitution. There we go. That's our reason. Substitution. Now we can do some simplifying. So 2 times 31 is actually 62. So measure of angle 1 equals 62 degrees. And measure of angle 3, equals, what's it, 60 or 93 minus 31, which equals 62 degrees. And that's called, in math, simplifying. So we could just put simplify, because we're just doing the calculations, the arithmetic. Then the final step here, I'm going to actually there's 2 steps, so we might have to continue it, but let's go ahead and see what we got. We can say that these two things are equal. Because they're equal to 62, we could say that measure of angle 1 equals measure of angle 3. And that is a substitution because we got 2 things equal to the same thing, so then we substitute them equal to each other, and that's it. Okay, so we're almost there. It's actually 2 more steps. So let's continue it on. Hopefully you have some more space below yours, but I gotta go over here. So now, as I'm continuing on, I said that they're equal, but for me to talk about corresponding angle postulate, I need congruent symbols. So I'm gonna say angle 1 is congruent to angle 3. And then on the other side, this would be the definition of congruent angles. Then the last step here is that they're parallel. So little c is parallel to little d. And it's the same thing that we were looking at before, because we found corresponding angles, 1 and 3, and we said that they're congruent. So they're corresponding and they're congruent, therefore the lines are parallel. So converse of corresponding angle postulate. Cool. All right, let's get into the second round here. Same idea. By the way, if you needed to see that again, there it is. And now we're moving on. So we can do the same thing, but with all the other theorems as well. And that's what I kind of scrolled right over there. But it's just pointing out that whether you have the relationships correct. So right now we're going to be talking about 4 and 5. So 4 and 5 are alternate interior angles. So all we have to do is set it up and then claim alternate interior angles and converse. So let's jump right into that one. So again, I'm going to split my stuff here. I think the statements will be a little bit shorter. So for my first statement, it's going to be angle 4 is congruent to angle 5, and that's given. And then now I can jump right into it. It's just J is parallel to K. And the reason why this time, I just have to make sure that I state the correct relationship. So it's the converse of, and this time 4 and 5 are alternate interior angles. So alternate interior angle theorem. There we go. Okay, now again, one of these longer ones, but that's okay. Let's see what we got. So for number 4, we're going to split it up. I'm just going to kind of split it this way. We know that we're doing statements on the left and reasons on the right. Let's see if we can fit them all in here. So the first thing is all that given stuff. So we got measure of angle 3 equals 12x. Measure of angle 5 equals 18x, and x equals 6, and that's given. So that's my 1a and 1b. All right, now let's again do just substituting and calculating those values. That would give me 12 times 6 for the first one, but I should say measure of angle 3 equals that. Measure of angle 3 equals 12 times 6. And measure of angle 5 equals 18 times 6. And let's see what we get from there. That's just a substitution. And then next we could say measure of angle 3 is, measure of angle 3 equals 12 times 6 is 72. And measure of angle 5, 18 times 6, that's a little bit bigger. That's actually quite a bit bigger. Let's see, how much would that be? That would be 108. Yep. All right, now here is what's kind of crazy. I know that measure of angle 3 plus measure of angle 5, if I were to add these two things, I could say this. Oh, and by the way, this is just simplifying. That's what we got here. Simplify. And then for 4a, I could say measure of angle 3 plus measure of angle 5 equals 72 plus 108. And what I did there was something really clever. So I took these two pieces that were equal and I added them equally to the first equation or the first setup in 3a. So when you add the same thing to both sides, that's called addition property of equality. Now that I've gotten that, the next step's actually pretty straightforward. We would say 5a, measure of angle 3 plus measure of angle 5 equals 180. And that's just simplifying. Simplify. And then the last part here, 6a. Well, what do we got? We got two angles here that add up to 180 and they're same side interior. So that tells me I can jump right to J is parallel to K. And my reason is the converse, because I'm proving parallel. Whenever you're proving parallel, you're going to use converse. That's like the theme of the day. So we're doing the converse of something. But what are we doing? And it's all dependent on that relationship of those angles. 3 and 5 happen to be same side interior angles. There you go. 3 and 5, same side interior. Okay. Now for this next one, it's actually, I think, a little bit shorter, or not necessarily shorter, but at least a little bit easier. Let's see what we're going to get here. So again, we're going to have, statements and reasons. It might help if we have a little bit extra space. Let's see if we can get that. We can just get up a little bit further, not a whole lot. I'll even cover up this down here just so we have that extra space there. Okay, so number 5 is what we're looking at here. Again, if you need to go back and see the other parts, just rewind the video, pause it there. Now I'm going to finish number 5 right now. So we start with the given stuff. Measure of angle 2 equals 8x. Measure of angle 7 equals 7x plus 9. And x equals 9. And that is given. Okay, now let's look at the last part. It says we can just plug these in just like we've been doing before. So measure of angle 2 equals 8 times 9. And measure of angle 7 equals 7 times 9 plus 9. Well, and that's just a substitution. Same as before. We're just plugging stuff in. Now we can simplify those. Well, 8 times 9 is 72. So measure angle 2 equals 72. And if we have measure of angle 7, 7 times 9 is 63 plus 9. Let's see, measure of angle 7 equals 63 plus 9, which is 72 as well. And that is simplifying, just doing the arithmetic. Simplifying. Okay, this is cool because they're both equal to the same thing, so that tells me I can say that they're equal to each other. Measure of angle 2 equals measure of angle 7, and that's again just a substitution. I substitute this 72 degrees for angle 7, and then I get it. So substitution. And then 5a, now I need to jump into congruence, because if they're equal, that's cool, but for me to use 2 and 7, which are alternate exterior angles, I need to use the congruent symbol to talk about that theorem. Okay, so angle 2 then is congruent to angle 7, and that is the simple definition of congruence, congruent angles. And then the final piece here, we say that J is parallel to K because why? Well, I hinted at it just a few seconds ago, but you got to do the converse of, and then you got to state the relationship of the angles. 2 and 7 happen to be alternate exterior, so converse of alternate exterior angles. And that's it. Cool. So hopefully that helps, especially as you guys are looking at the practice to do and such. If you need to, watch the video again, go back through it, see how it's done. And also feel free to collaborate with your partners as well.